An Introduction to Titration. This is Screencast 15.9. The main thing we're going to learn is how to do something practical. Precisely measure the concentration of an unknown acid or base. Somebody you know is dead on the floor and there's a liquid next to them and you think it's like some kind of acid. How are you going to figure out how concentrated it is? It's actually pretty easy and doesn't require any expensive equipment. It's a typical process for any forensic lab. Let's go ahead and check it out. Alright, so suppose you have 20 mils of nitric acid laying around on the ground. Yikes. I'd be scared too. That stuff dissolves metals, or reacts with metals. You have no idea how concentrated it is. How do you find out? Easy. Neutralize it with a base of known concentration. What a simple principle. The more base it takes to react with, the stronger it must be. Concentration of one thing times its volume will always equal the concentration of another thing times its volume. And if you know 3 of those 4, you're good to go. And look, you do. You have the volume of the unknown, you have the concentration of the known, and you would have the volume of the known, the amount that it takes in order to neutralize it. And there you go. So let's go ahead and do that. That relates to this formula. If you rearrange the C1V1 equals C2V2 and recognize that for concentration we're talking about molarity, it always ends up being this. So this is the formula I gave you. The molarity of the unknown is equal to the molarity of the known times the liters of the known divided by the liters of the unknown substance. So suppose it took 20, you have 20 mils of nitric acid. You don't know how concentrated it is, but let's say it took 43.33 milliliters of a 0.1 molar potassium hydroxide solution. How concentrated is it? Probably close to 0.2 molar, I think, since it took twice as much of the 0.1 molar. But let's go ahead and punch it into that thing. Let's see. The molarity of the known is 0.1, and so there it is. Why did I do 43? Oh, the liters. I did the liters of the known. I did 43.33. Notice that I didn't bother converting to liters because I recognized that milliliters over milliliters is going to cancel anyhow. So there's the volume of the known, there's the concentration of the known, and there's the volume of the unknown. Punch it in and it's close to our estimate, 0.2167 molar. For many of you, this now ends the course, but be aware that there's a couple topics that have not been covered in these screencasts, including Bronsted-Lowry acids and bases, as well as weak acids and bases. These may be covered at another time. And that completes the course.